All right, so welcome back to the Civil FE exam review. Today in this video, we're going to be looking at statics and continuing with statics. We're going to be focusing specifically on centroids of areas. And so some of you may not know what that is, what a centroid is, or you may have, gone through it in school, but you need a refresher. So today I'm going to go through and hopefully bring back some of the things that you covered previously. All right, so I have a few practice problems for you all. And we're going to start with number 1. So number 1 says, find the centroid of a half circle of radius 5 meters. Okay, so what information do they give us? Well, they give us that it's a half circle. They also tell us that the radius is 5 meters, and that's all the given information. And then we're trying to find the centroid. All right. So let's just imagine a centroid, right? Or what is a centroid ultimately? A centroid is just a point at the center of the given area. So in this case, we have a half circle, right? So I'm just drawing a half circle. Bear with me. And you have x, a y, and x coordinate. Here, right? And maybe our center seems like it would be somewhere right there, right? So that's what we're trying to find. Let's say this is the x and y coordinate system. So we're trying to find the point, the x coordinate and the y coordinate, and that is going to be our centroid. So let's dive into this a little bit more, and see if we can use our FE handbook to kind of solve for this. So I'm gonna search centroid, see what comes up. "22 things come up. Let's just hit. Okay, so centroid of an area is defined as, we could use this, the sum of the x's. So this here, the sum of the x coordinates multiplied by the areas, all divided by the total area. And this may make a little bit more sense later, but we're not going to use that for this particular problem. So the handbook, luckily, gives us some shapes. Okay, so these are triangles, area and centroid. So it gives us a chart. Those are not what we need though. Okay, circle, disc. All right, half circle. All right, so we got our shape. All right, now how do we read this chart? Well, to get XC, which is the center, the x coordinate, this is the x coordinate, and this is the y coordinate of the center of this shape. So we know that XC is equal to A, right? Okay. So what is A? Well, we know that this whole thing, according to the chart, is 2A. So in our case, we know that our radius is 5, right? 5 meters. So I know that in this specific case, then 2a is equal to 10, right? Because we got to add another 5 on this side. I know that 2a equals 10. So now a is equal to 5, right? Okay. So xc is equal to a, which is equal to 5. See where I pulled that from? I just took it from the handbook, right? Not that. This one. Okay. All right, let's find the y coordinate. And if we went through our answers, right, we could get rid of a because that doesn't match our choices. We get rid of b and c. So it really could only be d, but I want to show you how to get the y coordinate as well. All right, so let's look at the y coordinate. All right. So the y sub c is equal to 4 times a all over 3 pi. All right. If we plug in our a value, we get 4 times 5 divided by 3 pi. And when you total that up, you get y coordinate is equal to 2.12. Our answer is in fact D. So just remember your centroid is it's going to be a coordinate, and it's going to be at the center of your specified area. So something to keep in mind. All right, let's look at number 2. It says calculate the y coordinate of the centroid of a T-section as shown below. The dimensions of the rectangular part are 6 meters by 3 meters, and the dimensions of the stem are 2 meters by 1 meter. Okay. So let's start by getting let's start by going through what we're given. All right. So we're given T-section. They give us the dimensions of both parts, like the rectangular part and the stem part. And they want us to find the y coordinate. Okay, so let's draw this out to start. So I know that we have our rectangular part, and we have our stem. I'm going to show you what I mean by this. So from here, all right, they give us our dimensions. So this is 6 meters, right? We're in meters. And this is here to here. It's 3. Okay. And then from here to the bottom of this is 1 meter. Okay. And what's the width, right, of this little small piece? Well, from here to here is 2. Okay. Now, what formulas do we need, right? Because this is not just a one rectangle, it's 2 different areas, right? So I'm gonna go back to searching for centroids, and this is where we begin to get our y coordinate. All right. Centroid of an area, we can get our y coordinate by summing up all the y centroids times the area of that specific piece all over the area. So I'm gonna call, we're gonna say this is I'll say this piece, that's piece 1. And then the other piece is going to be my piece 2. Okay. All right. So what does it mean by the y centers? So we have y bar. I'm just rewriting our equation here. Is going to be equal to the sum of the areas times the y centroid of the piece all over the sum of the areas of all the pieces. Okay. So what is the area of piece 1, right? The area of piece 1 is going to be 2 times 1, right? And then we're going to multiply that by our y value. So what would be the centroid if we had a, say this is our, let's say this is our x and y axis, right? So x axis, and this is our y axis. Where is the center of this piece? That piece 1, and where would the center of piece 2 be? So the center of piece 1 would be, well, I know this, the height of this piece is 1, right? So half of that piece is 0.5. So 0.5. Okay. Now we're gonna add the area of the second piece. All right. So what's the area of the second piece? Well, it's gonna be 6 times 3. Okay. 6 times 3. Now, what is the center of the second piece in the y direction, right? So we have, we know that if we're starting, if this value is starting from the x axis, we're coming up 1 and then half of 3, right? So to get to that point, it's going to be 1. Why am I saying 1? Because we're going past this first, coming up past this block, right? And then we're stopping here. So from here to here. What is that distance? Well, that distance is going to be 1 plus half of 3, which is what? 1 plus 1.5. So it's going to be 3 divided by 2. Okay. All right. So now we have our, we should have all of our sum. We have all the top portion of this equation. Now we need the bottom portion. So what's the sum of our areas? Well, the sum of our areas is going to be 2 times 1, right? For the first piece. And then the sum of the area of the second piece, which is going to be 6 times 3. And this is going to give us our y coordinate of the centroid of this whole entire composite shape. Okay, so for y bar, we should get 2.3. So our answer is going to be A. So basically, if you get shapes that are not the norm, or the shapes that are not in your charts, and they put these composite shapes together, and you want to break it up into its separate pieces, and then figure out what you're solving for. So for in this case, we were solving for the y coordinate of the centroid of the entire shape. And so we needed to break them up into pieces and multiply our area times the individual centroids of the pieces. So it gets kind of complex, but once you understand what the symbols mean, then it's just a matter of practice. So here, let's look at number 3. All right, number 3 says, given the shape and the following, determine the x coordinate of the centroid of the shape. Okay. Knowns. The sum of x times a is equal to 49.7 inches cubed. X represents the centroids of each shape. A represents the area. Okay. So what information do they give us for this? Well, they give us all the dimensions, right? Dimensions. They give us the sum of x times a, which is very nice. That seems like that may save us some work. They also give us, I mean, yeah, the dimensions are important. You can see the shape. Okay. What are we trying to find? We're trying to find the x coordinate of the centroid of the entire shape, right? Okay. So what formulas do we need? Well, we're going to need to use x, the x coordinate of the entire. We're going to need to use this formula to get the x coordinate. So we can rewrite this as x. I'll just write it as x bar. So x coordinate of the whole shape is equal to the sum of x times a all over the sum of a. All right. Okay. So now it's just a matter of taking what we're given, right? So they give us this value, right? So now we're left, we can plug that in. So we could say x bar is equal to 49.7 inches to the third all over the sum of a. All right, what would the sum of a be? Well, it's the sum of our areas, right? So how do we get that? Well, we find the areas of each piece. Now, important to note that it looks like this trapezoid has a hole in it, right? And that's the circle, that it has a diameter of 2 inches. So what I think we should do to get the sum of the areas, right, is to go ahead, take the to get the sum of the areas, we'll take the area of the trapezoid and then minus the area of the circle, and that should give us what we need. So the sum of the areas is equal to, well, how do we get the area of a trapezoid? Go to Centroid, see if they have this in a chart for us somewhere. So if you didn't remember this, if you don't remember this, okay. So here, all right, it's 1/2 times the height, and then multiply it by a plus b. Okay, so we'll start with 1/2 times the height, which is what? What's our height of our thing? That's going to be this. This is our height. So 3. And then we're going to multiply that by a plus b. In our case, a is 4 inches here. Four, and then plus 8. All right, minus the area of the circle. All right, we know how to get the area of a circle, and if you don't, you can just pi a squared or pi r squared here. So minus pi, what's r? It's going to be 1 inch squared. All right, once you get that, you plug that in. And for the sum of your a, you should get 14.85 inches squared, right? All right, and so our x bar is going to equal 49.7 inches to the third over our sum of A, which is 14.85 inches squared. And you should get X bar to equal 3.34 inches. Okay. So basically, if we look at this, right, and we come along we just want to make sure that this answer makes sense, right? So we look at this, we can look at our X coordinate and our Y coordinate, and it says our X bar is going to be around, or the centroid of this thing is going to be around, for X, 3.34. So I'm thinking it's going to be about here, 3.34. And so that makes sense, right? It'll probably be about here, and I'm thinking for Y bar, it might be there, maybe. We didn't have to solve for Y bar, but you just want to make sure that your coordinate makes sense, right? If it was, sorry, okay. If our, so it's going to be B. But looking at this, if we went and we said the X coordinate is going to be at 1.7, or our answer choice of A, right? Well, we would say our centroid is probably about here, right? And to me, that doesn't look like the center of this shape. So being able to identify and make sure you understand what's going on is really, really important. So you can normally rule out certain answers. You know, it probably wouldn't be all the way at 6.3 either. Right? So that's probably about here. So I think that's not going to be at the center of the shape. Okay. So that concludes centroids. In the next video, we're going to be doing area moments of inertia.